Good morning, or actually good afternoon to everyone. My name is Pawel Wargocki, and I'm professor at the Technical University of Denmark. And my talk today is on a bedroom ventilation and its importance for the sleep quality. First of all, I would like to apologize for not being in person at the conference. Actually, we have been planning this for a long time with Alexander, but during October, we signed a contract and we are performing some measurements to meet the requirements of the contract this week. Therefore, I had to cancel my presentation. I'll make it up to the organizers of the conference in the coming years, which I promise. So apologies for not being present in Belgrade, and I hope you are enjoying the time there. My talk is about the sleep quality, but it's not about how I can put you to sleep, but it's about its importance for our life quality and our health, and what is the purpose of and importance of the bedroom ventilation in that context. So let's start with some important details that you probably know already, but I would like to remind you about those details in my following slides. First of all, of course, we know that we spend most of our time indoors. We are actually species, building species. We live in buildings most of our life, more during the end of our life or in the beginning of our life, less probably when we are in adulthood. But nevertheless, on average, we spend more than 80%, sometimes even 90% of our lifetimes indoors. This is basically the line that is present in nearly all papers regarding the indoor environmental quality and its impact on health. However, if we analyze carefully how much time we spend in different environments, we can realize that actually most of our time that we spend is in residential environments. And of that, most of the time is spent in our bedrooms. We spend very little time outside and still significant part in the commercial buildings, but less significant than the time that we spend in our homes. So our homes are really an important pathway for our exposures. However, if we look at the research that has been done in relation to our exposures and our health, most of the research have been concentrated on the exposures that are happening outside in an outdoor environment. And this is not to say that this research is not important, because we actually inhale the air that is outdoor air in the building. So outdoor air is really an important um, for our health, and this is important for our exposure. But the exposure is not happening outdoors, actually it's happening indoors. And then less research has been done on the commercial buildings, but our focus has been in the last maybe 20, 30 years, mostly on the commercial buildings such as schools, offices. And there was less, although increasing research on residential exposures. That we see in the last maybe 10, 15 years, a lot of interest in the studies related to our homes. However, those studies did not focus very much on our bedrooms. So there's very little research that has been done in relation to the exposures that are happening in our bedrooms. If we try to convert the percentages or the illustration here into the numbers or years, we will see that basically we stay only 6 years outdoors. If we decode the 80–90% of our exposure for a 79-year-old male, this is an average lifetime of a male in the European Union, we will notice that of this 79 years, we spent 6 years outside, about 4 years when commuting, which is a significant, actually, if we can consider that as the time that we spend actually in the transportation during our life. And 69 years in buildings, of which 59 years we spend at home, and 26 years when sleeping. So significant exposure time is actually during our sleep. So the question is sleep really an important for us? And what is the consequences of the poor sleep quality for our health? So in the last 10, 15 years, there have been more and more research published on the effects on the importance of sleep quality. We, our sleep researchers, provide us with information that we understand better how important sleep is for our life and for our health. So sleep quality is vital for humans, and sleep improves our cognitive performance, especially memory and learning and creativity, reduce health risks such as, risks for dementia, Alzheimer disease are reduced when we sleep well. It regulates hunger and fullness, so it may have consequences for our obesity, and then, of course, to reduce our sleep quality influence our ability to concentrate and a next day performance. So this is an important part of our life, not just to rest, but basically to provide a specific time for the processes that are necessary to keep our brain in proper functioning. Our brain, of course, is functioning most of the time, but as any other organ in our body requires maintenance. And this maintenance is actually happening during the night. Unfortunately, so in order to have a good sleep, we need to sleep at least 7 to 9 hours, 7.5 to 9 hours. Why, I will explain in a moment. And then, however, as we see from the studies that are performed and our life changes, we sleep less and less. So we sleep less than 7.5 hours. What are the consequences of that? I will say in a moment. So of course, there are sleep parameters that define our sleep quality, and sleep researchers defined the ranges of those parameters, which define good sleep quality, appropriate sleep quality, and poor sleep quality. However, there has been still a debate and there is not enough information on the physiological consequences of some of those parameters and direct connection with this. We have information for any group, population group, starting with children, young adults, and also seniors. Here there are examples for adult and young adult. And then we know that we should sleep around, as I told you, around 7 to 9 hours, and less than 6 hours is inappropriate. We should have a sufficient number, less than certain number of awakenings during the night. We actually wake up during the night. We don't even know about this. And then there has to be a sufficient efficiency of sleep. And also the time that is necessary to fall asleep should be below 30 minutes or something like that. So these are the parameters that define objectively our sleep quality. Also, there are other parameters that define it, and they are related with so-called sleep architecture. So during sleep, we have 5 cycles of about 1.5 hours, during which we are awake. We have a REM sleep and non-REM sleep. And those stages, as you can see, are of different lengths at a different cycle, and they serve a certain purpose. I don't have time today to speak about the purpose, but among others, they allow us to interpret the information that we get during the night. They allow us to move some of the information into the deep memory from the short memory or the long memory, and also allow us to clean our brain. An important thing is that you can see there are 5 cycles, and they different stages at different lengths in different stages, which would mean that if we sleep only 4 cycles, for example, then we will miss some part of important part for example, for REM sleep, which is for the interpretation of our um, of the previous day's events. Also importantly to say is that we cannot recover the sleep. So if we sleep short one night, maybe for the second night we can recover some of it, but if we sleep short for the entire week, and then we want to recover during weekend, that is impossible. So this is why sleep is important. It's important, and also important is because of there are some implications for the lost work. So these are the recent estimations that have been made for different countries like US, UK, Germany, Japan, and Canada. And what are the consequences when we sleep less than 6 hours, 6 to 7 hours for the work performance? So it's not a health, but it's a work performance. And you can see that for Germany, for example, we have, if we sleep less than 6 hours, we have about 200, the entire population has around nearly 200,000 days lost of work, which is a measurable or tangible economic loss. And it's only the consequences for next of the work performance. Here we do not speak about learning for children and also health consequences for the different other population groups, including the class that is actually working in offices. So there are some significant health effects, significant economic consequences of poor sleep quality. Then about the ventilation. So if we think about ventilation and air quality, we have to realize that we breathe enormous volumes of air during the day. So compared to, for example, amount of water that we drink during the day, and if the glass represents 1 liter of water, it's like 2 to 3 liters or 2 to 3 glasses of water that we drink during the day, but we breathe about 11,000 liters of air a day. And then, of course, a significant part of this, probably 1/3 or a little bit less than 1/3, because we breathe less frequent during the night, but let's assume 25%, so still significant, 2,500 liters of air we breathe during the night. And of course, this air has important consequences for our exposure, because if the air contains the pollutants, those pollutants will be penetrating our lungs and of course our body. So ventilation is important parameter to reduce those exposures to the pollutants indoors. So what is the bedroom ventilation? We looked at the standards and measurements that were performed in bedroom. We published the review paper in 2020 in Building an Environment that you see on the right, in which we try to look what are the conditions measured in bedrooms. And basically what we found out, it is very interesting observation, is that most existing ventilation standards do not prescribe specific ventilation requirements for bedrooms. If we speak about the residential environment, basically ventilation requirements are for generally for the entire dwelling, not specifically for bedrooms. Whether this is an overlook, I will speak about this in a moment. With respect to the measured ventilation in bedrooms, most of the information that we have are on the measured either carbon dioxide concentrations, and they range from very low levels of around 400 to very high levels of around more than 2,000. And also what has been measured in bedrooms is the air change rates that are, again, they are in a very wide range from 0.2 very low air change rate to 4.9 air changes. So basically, mostly CO2 and air change rates have been measured. And there is a wide range of those numbers. And then there is no regulations of what the requirements should be. This is just an example from the paper, very difficult to see and read perhaps, But generally, what we see is that the lowest observed uh, air change rates and the highest observed CO2 levels were in naturally ventilated bedrooms and during heating season. We also seen that the highest temperatures are actually in those buildings, in those bedrooms during non-heating season. But I'm not speaking today about temperature, about ventilation. So basically, and then if we think about what is the typical typology of bedrooms around the world, we will notice that most of the bedrooms actually around the world have natural ventilation. Very few have mechanical ventilation, either extract ventilation or the full mechanical ventilation. But these are not that prevalent as in case of the naturally ventilated bedrooms. So there is a potential risk and potential consequence of insufficient ventilation in those bedrooms. And what are the consequences for the sleep? We really, when we really don't know, or we didn't know maybe a few years back. We could expect that there are some effects, but there were not documented effects on the sleep quality. So this is a major question: so how much ventilation is needed in bedrooms? Is this 0.2 air changes per hour, or 3 air changes per hour, or 500 ppm, or 700 ppm a sufficient ventilation? We really don't know, and this is why we started the project. This project started before pandemic and then was run throughout the pandemic. And it's not yet completed, but most of the papers have been published. That we applied to ASHRA for the project on the effects of ventilation in sleeping environments. And the major topic of this research was to summarize standards defining bedroom conditions, summarize literature on ventilation and sleep quality, and perform cross-sectional and intervention studies in actual bedrooms to understand the consequences of ventilation on sleep quality in order to basically provide an amendment to ASHRA Standard 62.2 or any other standard that in the world that deals with the ventilation in residential buildings. We also, during this project, performed several other studies, actually that were not planned during the application process for the project. And some of them are described here. Most of them are actually already published. Some of them are still in the process of reporting. For example, we looked at the bedroom conditions prior and after the COVID-19 lockdown and trying to understand whether COVID-19 lockdown has changed some of the behaviors of the people in their bedrooms. We also, although not planned, performed laboratory studies on the effects of ventilation, pure CO2. So not only the CO2 that is emitted together with human bioeffluent, so CO2 as a marker of ventilation, but also the pure CO2 on the effects of sleep quality. Also, we looked at the temperature, ventilation, and noise on sleep quality. These were studies performed in the laboratory. We examine also how window and door opening behavior in actual bedrooms affect ventilation and sleep quality. And then, because we had very little information, we try to estimate what is the CO2 generation rate for sleeping people, both for young adults and elderly. And also we measured the bioeffluents that are emitted by people sleeping using a very sophisticated chemical analytical tool, which is called proton transport reaction mass spectroscopy time of flight. And then this data is still to be analyzed in the future. And also we compared the different methods for measuring sleep quality using low-cost sleep trackers against the actual laboratory-grade instruments such as polysomnography. This study is still, or these results are still in the process of analysis. So what we found, basically, this graph is very, very busy. But this is a summary of, to us, known studies examining the effects of ventilation on sleep quality, measured objectively. What means measured objectively? I will speak about it in a moment. These are the studies that actually were performed in the last 7 to 10 years at the maximum. And you will see there are some studies from 2016, but most of them studies, and 2018, but most of the studies are coming actually from the research that we have performed for ASHRA, and also research studies that were performed in parallel to those by other groups. And then they looked at the, in these studies, we measured sleep quality objectively, and there were different types of study. I will explain this in a moment. And then as a measure of ventilation, we used carbon dioxide as a marker of ventilation. And these studies were done for different population groups, adults, seniors, and also children. I'll explain them in a moment, but first explain what we did. So we measured objectively sleep quality, either using a polysomnograph or the actigraphy sleep trackers. Actigraphy sleep trackers basically monitor our movement during night and monitor how this movement will affect our sleep. Through monitoring movement, we can estimate the measures of sleep quality, such the length of sleep, efficiency of sleep, time awake after the sleep onset, and the sleep onset latency, so how much time it takes for us to fall asleep. And using polysomnography and some actigraphy sleep trackers, we can also estimate the or understand the so-called sleep architecture, so we can measure how long time we are in a different stages of sleep in different cycles. So this is how we measured objectively sleep quality. And also the studies were performed in different types of study was performed. There were laboratory experiments. So laboratory experiments were done basically in a climate chambers or in dormitories in which there were interventions made. And then there were field measurements actually as adapted dormitory rooms. And there were also field measurements which were performed in actual bedrooms. Most of those studies were actually made in field, and they were both intervention studies in which we modified ventilation by the opening doors or windows, or by changing ventilation in case the bedrooms had mechanical ventilation system. And there were also cross-sectional studies which were observing the conditions and correlating the conditions in bedrooms, ventilation conditions, with sleep quality. So basically, these are all the studies that we have seen. And first, we start with the gray studies on the bottom. These are the studies that did not show effect of changing the ventilation on sleep quality. And these were basically several reasons for that. Is that one of them is that it was the intervention by the door opening. So this is a finding from our study that shows that door opening in bedroom will not have effect on our sleep quality. And then there were studies in which pure CO2 was added to a bedroom, to the sleeping environment, and then there were no effect on the sleep quality. And then also there were some cross-sectional studies that did not show any effect because of other variables that probably interfered with the results. But most of the studies that we have looked at showed that there was an effect on sleep quality. And then this effect on sleep quality is represented by the black dots here, you can see. And one important information is that these are different effects on sleep quality. They can be represented by sleep efficiency or sleep onset latency, or effects on the different stages of sleep, such as REM and NREM, or deep sleep or length, or the percentage of deep sleep, or percentage of REM or length of REM. We did not differentiate this depending on what type of effects. We were looking at some effects, and if the effects was observed, we assumed that would have a negative effect on our sleep quality. We also did not assess the physiological consequences of this. I think even sleep research has troubles to assess that, even though they define the ranges of the good sleep quality and poor sleep quality. So we basically assume that if there is a significant effect on some of the parameters of sleep quality measured objectively, we consider this as the warning signal or a red lamp, and we should be avoiding this. So what we observed was that basically all the effects are happening at the CO2 levels, which are markers of poor ventilation above 1,000 ppm, and even some studies show that even at 1,000 ppm there is a negative. So when we are below 1,000 ppm of CO2, we can expect that there will be no negative effect on sleep quality. We don't know whether we should be at 900, 800, or 850, or 700. If we assume the average precision of the CO2 monitors, we proposed that we should be at the level of around 800, maybe 750 ppm. So ventilation that provides the CO2 level in a bedroom of around 750, 800, at least below 1,000 ppm, in order to avoid negative effects on sleep quality. We also asked the people to subjectively assess this sleep quality. Basically, a subjective assessment of sleep quality is that we ask people using the scale that was developed by sleep researchers, and based on their assessments, we estimate what is their score, and if the score is below 2, it is a good sleep quality. If the score is above 2, it is potentially poor sleep quality. And basically, we use this simple subjective method of assessment of sleep quality as well to estimate what would be the requirements for ventilation. Here we see that, again, that the levels close and below 1,000 ppm are actually having no effect on, there is no effect on sleep quality. Higher levels, they may be effects on sleep quality or may not. Probably we have to be, in this case, higher than 1,500, 1,800 ppm, so ventilation, in order to see significant effect. Still, and there is a larger part that of the studies that are not inconclusive. Nevertheless, I just showed this because it is an important illustration that there is also other methods subjectively measured. However, our conclusions are based on the objectively measured sleep quality. So, however, in order to convert the data from CO2 into the ventilation, we need to know the emission rate of CO2 for the sleeping people. This information did not exist, and existed only through the modeling and assuming what is a metabolic rate when we sleep. So what we did is we performed the studies in which we measured actually emission rates for sleeping people, both for the adults and the seniors, and we constructed basically what we call a sleeping capsule like this, and put it in our chambers and actually have people sleeping. And then we monitored the CO2 that was emitted by the people during the night. And based on this, we estimated what is an average emission rate of CO2 during sleep. We did it for adults, children, and elderly during different studies. And then also we had information for adults with the sleep disorders, and also compare this with the what is as suggested in the actual handbooks and standards. And we figure out that for most of those groups, adults, children, and elderly, of course, the children has a little bit lower and elderly lower than adults, is around 10, 11 liters per hour per person. And if you have sleep disorders, so basically you wake up at night and then you cannot sleep, your CO2 emission rate is much higher than 11 or 10 liters per hour per person. So with this emission rate, we were able to estimate what would be the ventilation requirement in a bedroom. So then we basically, for all the data that we have for emission rates, also from models, we estimated that in order to be around 800 ppm of CO2 in a bedroom, we need to have a ventilation rate of about around 10 liters per second per person. If we assume that 1,000 is our draw line, we are talking about 5 to 6 liters per second per person. But again, we have studies that clearly demonstrate that 1,000 ppm is too high level. So at this level, we could expect negative effects on sleep quality, so on disturbed sleep. So we need to be below 1,000. So probably CO2, ventilation rate with outdoor air that are above 6 liters per second, maybe 7 liters per second per person would be required per person in bedrooms. That would correspond to air change rates for the typical bedrooms that are higher than what is recommended today of 0.5 air changes per hour. So 10 liters per second would correspond to about 1 air change per hour in a bedroom. We are now analyzing, because you can see that below 1,000 ppm, the curve is a very steep. So we are analyzing now where we should be in that range, whether it is 800 or, but we have very little data in order to be able to estimate. So it is an estimate that it should be around 10 liters per second per person. I'll come back to this in a moment. So now, of course, you can ask, and you cannot see probably, this 1,000 ppm is been used for CO2, has been used for years as the indicator of poor and good air quality. It's assumed that above 1,000 is a poor air quality, below 1,000 is a good air quality, and it's based on the actually lecture that was done by, what was published by Dr. Max Pettenkofer in 1858. What he did is actually he measured in 9 residences CO2, and then he actually observed that there is palpable annoyance at the levels about 1,000 ppm, and there is comfortable occupants when the levels of CO2 are 600 ppm. And actually, the 600 ppm is very, very close to what is proposed by us. So he actually said that, and also he recommended that for bedrooms, the CO2 levels should be around 700 ppm. So our observation accidentally matched actually his recommendations. And if we look at the air change rates, what are typical measured air change rates in Danish bedrooms, we will see that if we want to be at a 1 air change per hour for children and in order to be at 1 air change per hour, this is probably only 20% of the bedrooms that have that high air change rate. Actually, most of the bedrooms have air change rates much lower than, in Denmark at least, in the bedrooms that the measurements were made, have much lower air change rates. And the air change rates for the 50% of the bedrooms in which the measurements were made actually are below 0.5 air changes per hour. So now, when we know this number, we could look at what are the ventilation requirements. And let's start with Denmark. So in Denmark, we have a building code, which is called Building Regulation 2018, which defines the ventilation in residential environments, 0.3 liters per second per square meter. And then there is also ventilation standard that defines in category 2 ventilation of 0.42 liters per second per square meter of floor. So if we take a typical Danish bedrooms, according to the statistical data, the average house is about 109 square meters with 2 people, and then the bedroom size will be of around 5 to 20 square meters. And then if we assume that average bedroom size of 13 square meters, then outdoor air supply rate per bedroom will be from 2 or 3 to about 5 liters per second. So if there are 2 people, then half of that, according to the building regulation and according to the standard ventilation standard, it will be 7 liters per second, which is about 3.5 with 2 people per person, which is much lower than what we recommend. And then if we take 0.5 air changes per hour as the air change rate in the bedroom, if the height is 2.5, we will have around the same number. Similar things we see, or similar numbers we see for the other Nordic countries. They are somewhat unclear and inconsistent across different countries. And generally, this is around 5 liters per second per bedroom. This is except Norway, where we have around 7 liters per second per bedroom, per person. And in major renovations in Estonia, the ventilation is 10 liters per second per bedroom in major, but it's still lower. If we, for 1 person bedroom, that will be enough, but not for the 2 or maybe 3 people when they sleep there. Sometimes parents sleep with their children. In Finland, the ventilation is defined between 4 to 6 liters per person for the entire dwelling. And this is unclear how it comes for the bedroom. And according to the present data, ventilation rate shall be around more than 6 liters per second per person. It's less than 1,000 ppm CO2. If we go to US, actually standard 62 defines ventilation based on the number of bedrooms. So basically based on the floor area and the number of bedrooms, ventilation is requirement. So if we assume the average US house is around 211 square meters with a median of 232 square meters, and then exclude wet rooms, and then we take an average bedroom size, which is around 6% of the floor area. It's similar as in Europe, basically. Then we see that depending on the number of bedrooms, we will see ventilation rates very, very small compared to our proposal, which means that bedrooms are basically underventilated in US. In China, the situation is slightly different. Actually, China has different documents that define ventilation in bedrooms. And basically, in some documents, the requirements are actually 1 air change per hour. And this is in document JGJ 134. And there is also some other standards that define actually ventilation of around 8.3, so around 8 liters per second per person, which would be close to our recommendations. Whether they are met in those standards in China is a different story, but nevertheless, there is some documentation that provides this information. So to summarize this information, we have to look at the ventilation requirements in the European standard EN 16798, which actually is a reference for many of the ventilation standards in the member countries and other countries also. And then actually these standards define what should be the CO2 above outdoor level for bedrooms, and actually defines for 4 categories of indoor environmental quality, defines those levels. And for category 1, which is the best category, it defines 380 ppm above outdoor level. So if we add to 420, we are about 800 ppm. So we are actually very, very close to or at the level that is recommended by us. So basically in bedrooms, in order to have undisturbed sleep quality, we would have to be in category 1. Probably we could also be in category 2, but certainly category 3 will have an effect on our sleep quality and will disturb our sleep quality. So one aspect is, of course, ventilation. The other is how the ventilation is working in bedroom. Just to wrap up and basically have some information. We also performed a study in which we looked at the combined effect of ventilation and noise on sleep quality. And actually, it was documented that poor ventilation reduced sleep quality, but ventilation noise was perceived as less acceptable and actually disrupted sleep, effectively canceling the positive effects of improving ventilation. We also see other effects of improved ventilation that are actually canceling the improved ventilation. For example, in China, we saw the effects of window opening, reducing CO2 levels in bedrooms, meaning improving ventilation, but having no effect on sleep quality because of the outdoor pollution and the outdoor pollution. Whereas in Denmark, actually, we saw the positive effect of opening the windows on sleep quality because of a low outdoor pollution. So we have to be very, very careful of those interacting effects and disturbing factor of ventilation. But generally speaking, ventilation, if designed properly, will improve our sleep quality, and the effects ventilation should be at providing the ventilation should be as such as that CO2 levels in bedrooms are below 1000 ppm, below 1000, not at 1000, and probably below 900 ppm in order to avoid disturbed sleep. So what are the takeaway messages from my talk is that the changes to standards may be necessary. So we have to start thinking about bedrooms. When we talk about residential environments, we need to speak about bedrooms separately from other spaces. And if we look at the European standard, only category 1 may provide sufficient ventilation in bedrooms. And basically on looking at our studies, they suggest that air change rates may need to be doubled in bedrooms in order to ensure that there is no disturbed sleep quality. Now, the question is, if we are increasing ventilation in bedrooms, first of all, how it can be done if we have so many bedrooms in which the ventilation has been already designed, and it will be very difficult to make retrofits there, or what are the consequences for energy? Because it's so many bedrooms, every one of us has to have a bedroom, that may have significant consequences for energy. So probably what we really need to think about is the intelligent designs and intelligent solutions for providing improved ventilation in bedrooms. Basically, during the night, we spend the time in bedroom. But in case the ventilation is provided to entire house, we ventilate the spaces and the rooms which are unoccupied during the night. So one of the potential intelligent idea for improving bedroom ventilation, in case that we have mechanical ventilation installed, is to redirect the air. So change the air distribution in housing so that the air will be following the occupants, meaning that during the night, the air from the other parts of the house or the dwelling can be actually redirected to the ventilation to improve to bedroom, to improve ventilation in bedrooms. But that requires additional studies in the future, but that could be a solution. So the improved ventilation in bedrooms may not have to actually cost much more. We need to simply start thinking differently about how the ventilation is provided in our residences. For those who are interested, I recommend to read our short column in ASHA Journal on the bedroom environment and sleep quality. This was published before we performed most of the studies that I showed, but actually provide a very nice overview of the consequences of insufficient bedroom environment on sleep quality. I would like to acknowledge all our team members. I'm presenting the results for many people that were actually obtained thanks to participation and work of many people. We have so-called World Champion team. It is 21 people here that actually contributed to all the research, and they are coming from different parts of the world, including China, Europe, and Japan. This is all that I wanted to say today. Unfortunately, I cannot take questions now, but any one of you who have a question, please send me an email and I will be happy to address any comments that you may have. Thank you very much, and I wish you a very good conference for the remaining part of the conference. So I'll stop here my presentation, and all the best to all participants. And of course, Merry Christmas to everyone because of the coming holidays. Thank you very much, and I hope to meet you soon in person at some of the events that are coming next year.